Then there are neural connections. And I'm going to go through this part really quickly so we can then talk about Form 1. I know you can't wait, right? Woohoo! Your first assignment. So neural connections. If you look at neural connections, basically we are generally talking about the physical brain, because the physical brain has neurons. And these neurons send signals to each other. They send signals through synapses. These signals tend to be both chemical and electrical. And some would argue there may be something else in addition to that. You go and look at some cutting-edge physiology research. What you find is that particularly in computing, we really have looked at the brain and how the brain works and what we know about the brain and applied it to computing. We've used it to improve how well computers perform. Right, so neural networks. Neural networks were created as a result of what we know about the brain. They used an analogy. There's a lot of cutting-edge research out there that's looking more and more at what we are learning about the brain every day and how can we use that to make faster computers, more efficient computers, have better computation. Things like parallel distributed processing also came from looking at how our neural connections work. You'll find a very, very direct analogy between those things. And if you even look at a lot of our cognitive tasks, again, looking at an analogy, a lot of cognitive tasks are understood computationally in terms of processing that simultaneously satisfies numerous constraints. Right? There is something that's called cognitive computing out there that's actually becoming more and more popular, where this is what they're looking at. They're trying to emulate how the brain works in computing so that they can make computing better, and so that it can help us model the brain and the mind and learn more about how we work as humans. So we actually have gotten quite a bit from neural connections.